All right, everybody, welcome to the video here for lesson number 7, finding volumes. So for the opening exercise here, I'm asking you to find the volume of a shoebox. A shoebox is traditionally going to be a rectangular prism, so it's going to look something like this. And we should remember from middle school, length times width times height. So go ahead, try and find the volume of this shoebox. Take a minute, pause the video, and see what you get. So if you found this volume correctly, we have volume is equal to 14 times 10 times 8. So the volume of the shoebox is 1,120. Just look, make sure that the units are all the same. They are, so we don't have any conversion issues. So here's the deal for this year's course. So we do have to be able to find volumes in some different shapes. Now, luckily for you on the Regents exam, there's actually a reference table. So I've cut out a piece of the reference table that's useful to you, and I've put it on this page in your notes. If you just Google Regents exam reference table, this pops up. So here's what your reference table will actually look like on the day of the Regents exam. There are some conversions up top that you will never need for this class. And then the whole left-hand side here is all about geometry. So there's your area formulas we did at the beginning of this unit, and then you have your circle stuff, and then all of your three-dimensional stuff. And then on the other side, there's all this algebra stuff that you don't need. So basically, if you are in geometry, you never need to look at this side at all. You can put in a big X through it on the reference table on the day of the Regents exam. So let's go back because there is something that comes up in two of these that I want to make sure that we notice. So if we see the word cylinder, sphere, or cone, the formula is what it is. So these are good to go. However, there are two formulas that have an uppercase B in it. And that's because they're generic formulas that work for any prism and any pyramid. So when we're talking about a prism, we're talking about something like a rectangular prism or even a triangular prism. So what would a triangular prism look like? It would be a triangle that looks something like this, right? You could have any shape on the base if you want. A pyramid, normally a pyramid has a square base. Whoops. So it looks something like this, where it's coming up to a peak, right? But it doesn't have to. It could have a rectangular base. It could look something like this, right? Where we have this like weird triangular pyramid with a rectangle base, right? So we have to be able to decipher what to do when the bases are different. That's what that uppercase B represents. So when you're looking at the uppercase B, that's talking about the area of the base, okay? The lowercase b, which you'll notice is in this formula up here for parallelogram and triangle, that represents the length, spell length right, of the base. And that's usually going to be in the formulas for two-dimensional figures. So we have to understand the difference. So when you see B as an uppercase letter, we're talking about an area. We're not talking about just a length. So let's play with these formulas. You probably have to go back and forth to this this piece of paper, or if you print out the reference table, you can just have it on hand. So let's take a look at a example here. So it says a shipping container in the shape of a right rectangular prism. So we have a rectangular prism. So this is going to be volume equals length times width times height. That's the only one that's not actually on the reference table. It tells us it has a length of 12.5 feet, a width of 8 feet, and a height of 9.5 feet. So we should be able to find that volume relatively quickly. All of the units are the same. So let's find the volume here. So we would say 12.5 times 8 times 9.5. So if we find this volume, just type it in your calculator, just how you see it. We get 950. It then says the container is filled to the max with bananas, which weigh 14.84 pounds per cubic foot. Each one of these is a cubic foot. So there's 950 cubic feet. So if we want to figure out how many pounds of bananas we have, we're going to take the 950 cubic feet that we have and multiply it by the amount of weight each cubic foot weighs. So if we take 950 and multiply it by 14.84, we get a total weight of 14,098 pounds. Seems like a lot, but that's not. All right, let's go to these newer shapes that we have to find the volumes of, like example 2. Example 2 is a great volume question because it's asking you realistically to do two different things. So here's our circular cylinder. So we have a cylinder. It has a diameter of 11 inches, which means that the radius is 5.5 inches. That's important because we have radiuses in the formula for a cylinder. Now, if you look on the reference sheet, the volume for a cylinder is pi r squared h. Now, this 14 inches is this diagonal side across the cylinder. It is not the height. The height is here. Now, if you look, even though it's a cylinder, this is still a right triangle. So to find the height, we have to do a Pythagorean theorem question first. So we're going to say the height squared plus 11 squared is equal to 14 squared. Notice I'm using the whole diameter because that would make the whole triangle happen. So if we do some algebra here, do some subtraction. So if I do 289 minus 121, we get 168. So the height is equal to the square root of 168. Now, the square root of 168 is not actually your answer. So if you type that in the calculator, square root of 168, it's going to give you a decimal. It's going to give you 12.96 something. Let's just leave the square root of 168 because we could type it in later. This way we don't mess up anything by rounding too much. So let's go back to working on the volume. So now we know the height, we know the radius, we know the volume formula. All we now have to do is plug everything in correctly. So we'll say volume is equal to pi times 5.5 squared times the square root of 168. I know this looks messy, but just type it in your calculator. That's why you have a calculator on your desk, hopefully. So we have pi times 5.5 squared. And again, type this in with me. Make sure you're getting the same answer, times the square root of 168. It says nearest hundredth, so this would be 1,231.77. If you don't have a calculator, remember you could always go to Desmos and they have a calculator right there for you. Okay, let's go on to another one. So here we want to find the volume of a triangular prism. Now if you look, there's no formula on the reference sheet that says triangular prism, but there is one that says regular prism. So when we find a volume of a regular prism, we're going to find the area of the base and multiply it by the height. Now we have to identify what the base is in this case. Bases are going to be the two sides of this three-dimensional figure that are parallel to each other. So in this case, the bases are the triangles because they would be parallel to each other. These triangles would never touch. All of these other rectangular sides touch each other, so they're not parallel to each other. So the first thing I have to do before I find volume is, well, I have to find the area of this base. Luckily for us, we know how to find the area of a triangle. If we don't remember the formula, it's right on your reference sheet. If I just look at this triangle here, the height is 7, the base is 6. So I can say the area of the base of this three-dimensional figure is 1/2 times 6 times 7. So the area of this base is 21. Now, when we're talking about three-dimensional figures, when we say the height isn't necessarily the distance from top to bottom and how the picture looks. The height is the distance between the bases. So this 10 inches, this winds up being the height. So again, the height is going to be the distance between bases. It's important to know. So then the volume of this figure is going to be 21 times 10. So the volume of this triangular prism is 210. Hopefully you're with me so far. So let's keep going. So example 4 gives us a pyramid. So here we have a pyramid. It says a square base of a pyramid is shown below. The altitude of the pyramid is 12 inches. Altitude is the fancy name for height. So if we see altitude, we're excited because we already know one of the parts of our formula. It then talks about how the pyramid is filled 3/4 of the way with water. That's talking about volume. So before we can deal with the 3/4 piece, let's talk about what is just the volume of this pyramid. So if I want to find the volume of a pyramid, it's 1/3 times the area of the base times height. That's right on the reference sheet. I'm not coming up with that out of thin air, right? I'm going back and finding that on the reference sheet. Well, what's the area of the base? The base is a square. So the area of the base is going to be side squared. We remember that from middle school, hopefully. So if we say the area of the base is going to be 6 squared, so the area of the base of this pyramid is 36. Now we already know the altitude is 12, so we could say the volume of this pyramid is 1/3 of 36 times 12. So if I do that, I get 144. Now that volume is for the entire pyramid. So it says if the pyramid is filled 3/4 of its capacity with water, how many cubic inches of water will be in the pyramid? So if I fill this 3/4 of the way with water, so here's all my water, I have 3/4 of this volume is water. So I could say 3/4 of 144. Type it in your calculator, and we get 108 cubic inches of water. So I'm mixing algebra with a geometry problem. Finding the volume, that's geometry. Okay, let's keep going. So this last one that we're going to do here in this video is a composite shape. So a composite shape is where we have two completely different figures, and we have to add the two volumes together. So it tells us to show our answer in terms of pi, so we want to make sure that we leave everything in terms of pi, just like we did in a previous lesson. But this figure has some things that we have to do some thinking about. So we have two different volumes we're trying to find. The volume of the cylinder and the volume of the hemisphere. I'll use C for cylinder, HS for hemisphere. Volume of a cylinder, we know right from the reference table. It's pi r squared h. Hemisphere is not on the reference sheet, but sphere is. So the sphere volume formula is 4/3 pi r cubed. So if we want to find a hemisphere, that's half of a sphere. So a hemisphere volume formula would be 4/3 pi r cubed divided by 2. It's the same exact formula. We're just dividing it by 2 because we only have half of a sphere. So let's plug in what we know. Let's first look at the cylinder. Cylinder has a height of 15, has a diameter of 15, which means the radius is 7.5. So if we find the volume of the cylinder, we're going to say pi times 7.5 squared times 15. Now if I type that in the calculator with everything but pi, because it says in terms of pi, I'm going to do 7.5 squared times 15. Again, notice I'm not typing in pi. So I have 843.75 pi. The volume of the hemisphere is going to be a little bit harder to figure out. So notice nothing's labeled on the hemisphere, but the nice thing about a cylinder is whatever the base is the same on the top, because both of them are really bases. So this hemisphere actually has a radius also of 7.5, because it's the same radius on top and bottom. So when we plug this in, we have our 4/3 pi r cubed over 2. So I'm going to say the volume of the hemisphere is going to be 4/3 pi times 7.5 cubed over 2. Now to plug that into your calculator, just be careful, all right? I actually am going to do it in 2 steps. So I'm going to type in 4/3 times 7.5 cubed. And I'm going to hit enter. That gives me everything that's not divided by 2. So then if I divide that by 2, I get a volume of a hemisphere of 281.25 pi. Again, it's in terms of pi, so I'm typing everything in but pi. So how I type that in one more time for you is I typed in 4/3 times 7.5 cubed. I hit enter. Then I hit divided by 2 to divide the previous answer by 2, and that's where the 281.25 came from. Now to find the total volume, we'll write total here for the total volume. I'm just going to add these two things together. 843.75 pi plus 281.25 pi. Now, when adding things in terms of pi, it's just like adding with variables, right? Pretend pi is an x. I'm just adding the two numbers together. So if I do 843.75 plus 281.25, I get 1,125, but it's in terms of pi, so we'll say 1,125 pi. Hopefully this video helps. There'll be a separate video there for your homework. Make sure you're trying the homework before you actually watch the video, right? Just watching a whole bunch of videos and not doing anything on your own is not going to help you here, right? If you have to, look back and rewatch the homework video or rewatch the notes video. Make sure that you understand the concept moving forward. Hopefully I see you soon.